Welcome back, Algebra 2. We're in lesson 119. From lesson, from lesson 99, we recall that the absolute value notation with a variable usually implies two answers. For instance, if we had something here, let's say x is equal to 4, then the x would equal either -4 or a +4 because we know that the absolute value of either one of these would equal 4, right? So the absolute value of a -4 or a +4 would equal a +4 because 1, 2, 3, 4 is the distance from 0 on either side in or on the number line, right? An absolute value statement of less than tells us that the value of the variable lies between a positive and a negative number. So for instance, the absolute value of something is less than 4 in the domain of the reals. It tells us the value is between 4 and -4. So we would actually circle the 4 here, and we would circle the -4 here, and we would indicate all of the real numbers between those two values, and we would not include those values. We would have an open circle because there is no equal sign underneath here. So we could actually write the statements of the something is greater than -4 and something is less than a +4 to get the conjunction here that -4 is less than something and something is less than 4. So we can combine those two together when we have the opposite symbols there. Thus we see that an absolute value statement of less than can be replaced with two statements that do not contain absolute value but place the same restrictions on the variable. So the value here is reflected in the conjunction here, which we write like this. So let's jump into example problem 1. Here we have the graph, the x that is a member of the set of real numbers such that the absolute value of x minus 2 is less than 4. We know that if the absolute value of something is less than 4, then something is greater than -4 and something is less than +4. So in this problem, something is x minus 2. So x minus 2 is going to be greater than -4, and x minus 2 is going to be less than +4. And then we're going to solve for x. So we would add 2 to both sides and find that x is greater than -2, and again add 2 to both sides and find that x is going to be less than 6. So all the real numbers greater than -2 and less than 6 will satisfy the given inequality. So we would draw our number line, and let's fix that up right quick. So we would circle -2, and we would circle +6. Let's see if we can put this in a conjunction format. So over here I'm going to write x is less than 6, and I want to flip this one to show that it is less than also, so we can get the numbers in between. I'm going to say x is, and if you notice the greater sign is opened to the x, so we open the greater side to the x, and then we put -2 over here. So we can write this conjunction like this, and we now can see we have -2 is less than x, which is also less than +6. And that is how we would write this conjunction as well. That would be the solution set to this. Sometimes it helps understanding to check one of the solutions. From the graph we see that a +3 right here would fall within these numbers. So we're going to check and see if we got the an answer that satisfies the condition. So we have the absolute value of x, which we're going to substitute in positive 3, is less than 4, because that is what we're given up here. So we're going to just pick 3 here, put it in. 3 minus 2 would be 1. The absolute value of 1 is 1. And 1 is less than 4. So let's see if we pick a number on the outside. Let's pick a number here. Let's say greater. Let's do 8, right? So if we sub in 8, 8 minus 2, less than 4. 8 minus 2 is 6. The absolute value of 6 is 6. 6 is not less than 4. So therefore 8 cannot fall within the realm of the possible answers. And so this checks out. So let's try a negative number and see if that works. So we're going to pick negative 4. So if we put in the absolute value of negative 4 minus 2, well, negative 4 and negative 2 is going to be a negative 6. The absolute value of negative 6 is a positive 6. Positive 6 is not less than 4, so therefore that's true also. So just the numbers within this area, within what we've decided is our conjunction answer, will solve and be true for this statement. So sometimes pick a few points on the inside and the outside. Even pick the ones on the external side, like the negative 1 and the positive 5, and check those and make sure you have your range correct. And that's a way that you can check to make sure you've understood the problem. So let's do another one. So in problem 2, we are told to graph x as the set of numbers where x is a member of the integers, such that the absolute value of x plus 2 is less than or equal to a positive 3. Normally, this would have been written where we have x plus 2 in absolute value symbols is less than or equal to 3, and then we have the colon with the domain of integers. But by using the integer symbol within this set here, we don't have to do all that. That's eliminating that step. That's the benefit of learning those symbols. We can just skip writing the domain information and put the domain into the problem itself. Here, our something is less than or equal to a positive 3. So the absolute value inequality can be replaced with something is going to be greater than or equal to negative 3. And our something is x plus 2 is going to be greater than or equal to a negative 3, and x plus 2 is going to be less than or equal to a positive 3. So when we do the math, we subtract 2 from both sides. Here we find that x is going to be greater than or equal to a negative 5. And when we subtract 2 from both sides here, we find that x is going to be less than or equal to 1. So that allows us to graph. Well, first let's create our conjunction. So we flip the less than part. We say negative 5 is less than or equal to x. And we pick up on the x here. X is less than or equal to 1. And this is the conjunction that we are going to graph. So we take our little red pen here and we circle the 5, and we're going to fill it in because we have that or equal to statement. And then we are going to find our positive 1. We circle that, and it has the equal to statement on it as well. So we fill that in, and then we draw our line between the two. You know what? That's not right at all. Let me take the line off. Because our domain is integers, I forgot to take that into account. So we're just going to dot our integers. Just like that. And we're going to include 0 because 0 is included as an integer in the domain of integers. So be careful of that. I made the mistake for you, so you don't have to do it yourself. You can learn from me and my mistakes. Z, we have to remember the domain that is being given. So it might take you a minute to switch back and forth, to switch from, not seeing the domain written out for you and it being in the problem, you might have to adjust just a little bit and remember that. It might even help you to write it down. Like just make a little note, integers. It's integers. And circle it. If that helps you to remember which one to graph, that's fine in your notes. But do remember to look for your domain right here, or you'll get the wrong answer. Just like I did. Even though I got the right beginning and the ending, I didn't have the right domain, so I drew the line, and that was incorrect. It was just the dots on the integers themselves. So let's do 119.3. This is the same statement as the one we did before, except that here something is x minus 2 instead of x plus 2. And also, instead of being in the domain of integers, it's in the domain of real numbers. So we will use the line this time. So if we replace that something with x minus 2, we get this right here. We get x minus 2 is going to be less than negative 3, and x minus 2 is going to be greater than positive 3. All right, and the reason we flip the symbol is because we are multiplying this times a negative 1. So that makes us flip there. So now we're going to add 2 to both sides and add 2 to both sides here. And we get x is less than a negative 1. And when we add 2 to both sides here, we get x is greater than a positive 5. So when we write our statement, we actually can't write a conjunction statement, because if we tried, we would say that negative 1 is greater than x and x is greater than positive 5. So we can't really write a conjunction. That does not work. So what we have here is a disjunction. So these would be or statements, and they would stand alone. So we would circle, because we don't have an equal sign, the negative 1 here. And x is going to be less than negative 1, so it's going to go to this side. And then we would circle negative 5 here. And x is going to be greater than the positive 5. Sorry, I said negative 5, positive 5. So we're going to go to the right here because x is going to be greater than 5. So we have a disjunction in this case. So you can see that would just be written just like this. X is less than negative 1 or greater than positive 5. We cannot combine them because they cannot form one single statement. They are going to be written separately. All right, so let's do one more. All right, so here we have graph x as a member of the set of integers such that the absolute value of x plus 2 is greater than 4. All right, so if the absolute value of something is greater than 4, then something is less than negative 4 or greater than positive 4. So we are going to set that something of x plus 2 less than negative 4, and x plus 2 is going to be greater than positive 4. So we are going to subtract 2 from both sides. X is less than a negative 6. And subtract 2 from both sides. X is greater than a positive 6. Or I'm sorry, positive 2. So we could see here we have another disjunction where we have x is less than negative 6 and x is greater than 2. And if you look, we are in the domain of integers. So because it's less than negative 6, we're going to go to the next integer, which is negative 7, and dot it and dot the 8. Okay, and then we can highlight that arrow on the end to show that it continues. And if x is greater than positive 2, we can't include 2. So we go to the next integer that is greater than 2, and that would be 3. And we would dot all the integers to the end and then highlight that arrow to show that it continues. Okay, and that is how we would write this disjunction. So something that you can notice here is whenever you have a greater than symbol with the absolute value, you're going to have a disjunction. You're going to have two separate statements. Whenever you have the less than or equal to, and again, this would be the greater than or equal to or greater than, and this would be the greater than or the less than or equal to or just the less than, then you're going to have a conjunction where you can graph them together as a single statement. All right, so those are the two main differences that you need to look for. Is it less than? It's going to be a conjunction. If it's greater than, it's going to be a disjunction. All right, and that's all we have for lesson 119. I will see you in lesson 120.